Sustainability, although a buzzword, is rarely measured in manufacturing companies operating in the world. Measuring CO2 emissions and usage of renewable or green energy have become preferred choice by conveniently overlooking water and land pollution. Cost to Earth model proposed is a step towards it, taking all three components into consideration. First, let's start with addressing the land pollution. BOM sustainability model is the first step towards measuring land pollution and operationalizing the circular economy, with two fundamental scores as the backbone. First, the circularity score calculated at the production or the supply side, and the cost to Earth score measured at the consumption or at the demand side. Let's look at the classical supply chain architecture consisting of 5 tiers spanning from suppliers at tier 1, manufacturing facility at tier 2, distribution center at tier 3, online or retail store at tier 4, and end customer at tier 5. There is a movement, a flow of products, information, and financials across these 5 tiers of the supply chain. Operationalizing circular economy deals with the 3 out of these 5 tiers, namely supplier and manufacturing facility at the supply side and customer tier at the demand side. Let's take different product examples that we use on a day-to-day basis, like handheld device, milk or a yogurt, a razor, a perfume, etc. They are made of different components, also called as a bill of materials. These BOM components are procured from different suppliers in bulk and are used for manufacturing a product. Like plastic, rubber, metal, each of these have a different decomposition time. Defining the end-of-life goal for all the BOM components that remain extractable at end of the product usage is what operationalizes the circular economy. For an example, a yogurt, a shampoo, or a perfume is used leaving its container behind. Entire razor or mobile remains extractable at the end of its life. Product can be manufactured using components which are newly procured, that is virgin, freshly extracted from the earth, or recycled or reused components. A set of components that remain extractable at the end of a life are called as EBOM, or extractable or end-of-life bill of material. Unconsumed extractable components, the EBOM remains, which must be discarded after the usage of the product. Sometimes it can be the packaging, or it could be the product itself, not useful to the consumer anymore. Setting a target for these EBOM for reintroduction into a new product to give it a new life without being discarded is what drives the circular economy. A year-on-year target set by the company's visionaries, made viable by the company's operations teams close to the ground reality, ensuring that the procurement and the production plans are in line with the target set, making it viable for different manufacturing units to use these EBOM in manufacturing a new product or using it as a new BOM. And we calculate the circularity score for a specific product manufactured in that specific product or a specific plant. Demand for a product can come from any part of the world. More often than not, the goods are sold in a country different than where it is manufactured. Cost to Earth score is measured at the sold to country depending on the viability of recovery and reintroduction of these EBOM. I propose a 3-step approach for operationalizing circular economy, each of which might take a year or more depending on the maturity of the company, enabled and tracked via IT solutions. Step 1 is to segregate, Step 2 is to measure, and Step 3 is to create cyclicity. Let's look at each of these steps in creating. Take any product. We need to determine which BOM components can be extracted at the end of its life and what is consumed by the user. Keeping the model very generic for any product manufactured under the sun. To each of these EBOMs, we need to define the end goal, whether it is decomposed, needs to be recycled, or reused. Here, reuse refers to recovery via internal supply chain of the manufacturer for reintroduction. Recycle refers to external supply chain for reintroduction, while decompose refers to no supply chain, with EBOM finding its way into the landfill. Depending on the EBOM finding its way as a new BOM for a new product manufactured in a specific manufacturing plant, circularity score is pulled. Stage 2 is to measure. Different EBOM have different end-of-life purposes. A percentage post-wear and tear is assigned to an EBOM. And also, incentivizing e-bomb recovery by setting a nominal value, like something followed in a beer industry, a 10 cent for a bottle, cap or crown getting 1 cent maybe. Finally, the remaining components need to be decomposed, leaving the Mother Earth to work its magic. Based on the volume of these e-bombs which need to be decomposed, a specific amount of space needs to be reserved in the sold to country for a specific period of time, unless recycled or reused. This is the cost to Earth score. This measures the practices adopted by the manufacturer in the sold to country and also evaluating them against their peers, avoiding countries as dumping grounds. Last and final stage is to ensure that the cyclicity is created, preserved, and where possible, improved. Year-on-year targets are set for both circularity and cost to Earth to improve practices adopted at both the production and also at the consumption side of things. To strengthen this, there is need to involve other stakeholders and facilitate circular economy. Now, e-bombs recovered having similar material types can be reintroduced into other supply chains, further strengthening and boosting the economy. Government can aid and facilitate these via different channels, be it segregation, public awareness, or mandatory fund allocation.